Now I am going to teach 11th standard physics lesson number 3, content number 3.7.2, vehicle on a level circular road. So when we are traveling in a vehicle, for example we are traveling in a bus or car, it's taking curved path near road, there must be acting centripetal force. Due to the centripetal force, the vehicles taking curved road. Consider a vehicle of mass m, it moves velocity v, it taking curved path radius r. So here three forces acting: gravitational force, normal force, frictional force. So gravitational force mg acting downwards, that is acting towards the center. So gravity pull the body is known as weight w equal to mg. So gravitational force acting on the vehicle towards the downward, towards the earth, that is downward direction. Another force, normal force n, the normal force acting in upward direction. Third one is frictional force. So already I thought a vehicle taking curve on road, in between the tire and the road, that is top of the road, bottom of the tire, acting frictional force. The frictional force acting horizontally inwards along the road. Suppose the road is horizontal, the gravitational force acting downward and normal force acting upward, both are exactly equal and opposite direction. So here the static friction, that is static frictions acting between the tire and the road, the static friction provides centripetal force is acting along towards the center. Static friction Fs, force which opposes the initiation of motion of an object on the surface is called static friction. That is, body is at rest, so frictional force is acting, that is called static friction. Static means body at rest. When a body is at rest, there are two types of force acting: gravitational force acting downward direction, normal force acting upward direction. The two forces are equal in opposite direction. So the body is at rest, the body doesn't move. So force which opposes means reduces the initiation of motion of an object on the surface. That is called static friction. Static friction Fs mv square by, that is centripetal force mv square by r. Static friction provides centripetal force towards the circular road. So Fs equal to mv square by r. So the static friction can increases from 0 to maximum value. Fs is less than or equal to mu s mg. So here mu s is coefficient of static friction. Fs equal to mv square by r, frictional centripetal force. Coefficient of static friction Fs is less than or equal to mu s mg. So substitute the value, equate this to equation mv square by r less than or equal to mu s mg. So m cancel, b square by r less than or equal to mu s g. So mu s less than v square by r into g less than or equal to mu s. So v square less than or equal to mu s or g. So v less than or equal to square root of mu s or g. There are two conditions are possible. Condition 1, safe turn. The coefficient of safe turn. Condition 1. The static frictional provide necessary centripetal force. The car will bend on curve. So the coefficient of static friction mu is determine what maximum speed the car can have for safe turn. Conditions 2. The static friction cannot provide necessary centripetal force. The car will skid. So mv square are greater than mu s mg or mu s less than v square by rg. This is conditions for skid.